Hi everyone. In this lesson, we're going to practice writing proofs involving angles. And our first proof says, prove that vertical angles are congruent, and we're given the diagram with the information on the diagram. And the diagram shows that we have two straight lines that intersect, forming four angles. And in this case, we will have two pairs of vertical angles. Angle X and angle Z are vertical, and angle W and angle Y are vertical. So you can choose any of these pairs of vertical angles, but I have decided to use angle W and angle Y. So if I use these angles, our proof statement will look like this, which it's already written. It would be prove that measure of angle W is equal to measure of angle Y. So this would be the conclusion that we want to get. So once we get to this statement, the proof will be over. So this would be the conclusion. Which means that this will have to be our last statement in the proof. So very important when we are writing proofs is that whatever you are trying to prove, such as in this case, we're trying to prove that vertical angles are congruent, we cannot use any information about vertical angles in the proof. So we have to sort of make ourselves believe that we do not know that vertical angles are congruent because that is actually what we want to prove. So forget about that, pretend that we do not know that vertical angles are congruent, and we're going to show that vertical angles are congruent. So we can use any other information that we know, we can use any other theorems, any other definitions, any other properties, but not the fact that vertical angles are congruent. That's very important. Whatever you are proving cannot be used in the proof. So the first thing that we want to do whenever we're writing a proof is we want to plan the proof. Always, either you do it mentally, or in this case, we're going to be doing it in writing. And then you write the proof. So I have two questions, actually three questions here to guide you in the planning. And the first one says, what do you know about angle W and angle X? The second one would be, what do you know about angle Y and angle X? And the third one is, what conclusion can you draw based on what you know? So we take a look first at angle W and angle X. What do we know about it? So well, if we look at the diagram, angle W and angle X, they are forming this line over here, which means that they are a linear pair. And what do we know, or what conclusion can we get from that, is that linear pairs add to 180. So I know that these two form a line, and therefore they together add to 180. So I'm writing that here in my plan. Measure of angle W plus measure of angle X is equal to 180. And why do we say that? Is because they are a linear pair. So next we take a look at the second question, which is, what do you know about angle Y and angle X? Well, if we take a look at these two angles here in the diagram, angle X and angle Y, they form this other line, so which makes again them a linear pair, and therefore they also would add to 180. So I'm going to mark here in the diagram with blue. They form a line, and therefore they together add to 180 degrees. So I'm writing that here on my plan. I know that the measure of angle X plus the measure of angle y, it's also equal to 180 degrees, and that is because of the same reason from the previous one. They are a linear pair, and therefore they are 280. So now if we look at the conclusion that we want to get, which is up here, measure of angle W is equal to measure of angle Y. It's only one equation, but right now we have two equations. So we want to combine these two equations into one, and we know that the properties that we have would allow us to do that. So we have the property of substitution, or the transitive property. In this case, we're going to use the transitive property because we have two quantities that look different, this one and this one, but both of them are equal to the same quantity, 180. Therefore, they had to be equal to each other. So these two quantities that look different are really equal to each other because they are both equal to 180. So the measure of angle W plus the measure of angle X must be equal to the measure of angle X plus the measure of angle Y. So again, we compare with this equation to the conclusion that we want to get, and they look pretty much different. But if you notice, on the left side, we already have measure of angle W, and on the right side, we have measure of angle Y. The only thing that we have extra here is the measure of angle X, which is repeated on both sides. So I need to get rid of that. If I get rid of that, then I have exactly what I want. So how do I get rid of that? Well, we have addition over here, therefore we need to subtract. So I'm going to subtract measure of angle X here, and I have to do the same thing on the other side. So I subtract measure of angle X, which would allow us to cancel here and on the other side as well, leaving us with exactly what we want. Measure of angle W is equal to the measure of angle Y. And of course, we need to talk about the reasons why do we have this. That was because we use the transitive property. And here it's because we use subtraction, or the subtraction property of equality. So when you're doing the proofs, you don't actually need to show the step where you are subtracting. You can actually jump from this statement to the conclusion, which is the result of the subtraction. So you don't really need to do this. You don't need to show this. So now that we have the plan, we should be going to write the proof, but I have the proof already written. But the proof should be exactly what we have in the plan. So after you plan, writing the proof is just a matter of writing the steps in a very clear and organized way. In this case, we're going to be writing complete definitions or complete theorems as the reasons. When I do the plan, I just write it in a simplified way over here, the reasons, but now in the proof, the reasons should be complete theorems or complete definitions. So notice that I have exactly what I have in the plan. So my first statement is measure of angle W plus measure of angle X is equal to 180, and it's because linear pairs add to 180. Complete the theorem. The second one is measure of angle X plus measure of angle Y is equal to 180, and the reason for that is because a linear pair or linear pairs add to 180. Notice that these two statements have the same reason, so that means you could actually put both the statements into one step, but I just decided to put them in separate steps. And then in step number 3, I have the two equations combined into one. So measure of angle W plus measure of angle X is equal to measure of angle X plus measure of angle Y. And that is because we're using the transitive property to combine these two equations into one. And then I show the subtraction here, which you really don't need to do. You just need to write the result of the subtraction, which is measure of angle W is equal to measure of angle Y, because we use subtraction, so it's subtraction property as the reason. And that's the proof number 1. So we are now going to proof number 2. Again, I'm hiding the proof because we want to sort of start from 0. But let me show you the complete instructions here. It says, prove that measure of angle X plus measure of angle Y is equal to the measure of angle Z. And then I have some information extra here, which says, for this diagram, you will need to add a label to the diagram. So whenever you need to add a label, you are free to do that. In this case, I already did. The angle that was missing, I labeled it angle A. And so I have all the information that I need here. So you always can add any labels, but make sure they are on the diagram. You have to put it on the diagram so that I understand, I can see what is it that you're talking about. So looking at the proof statement, we're not proving just any statement, we're proving actually a theorem. We're proving the theorem that says that the exterior angle is equal to the sum of the two opposite interior angles. So angle Z is the exterior angle, and angle X and angle Y are the opposite interior angles to angle Z. So we're proving an important theorem that we have already been using in the class. The same thing in proof number 1, we also proved a theorem, which is the theorem about the vertical angles. So again, in this theorem, whatever you want to prove, you cannot use in the proof. So you cannot use the theorem about the exterior angles anywhere in the proof. We're going to use any other facts that we know in order to get to this conclusion. So this should be our conclusion. And so this would be the last statement in the proof. So again, I have guiding questions for you here. And the first question says, what do you know about the interior angles of the triangle? And that's why we needed to put the angle A, because those would be the 3 interior angles. And the second question says, what do you know about linear pairs of angles? In this case, it refers to angle A and angle Z, which is a linear pair of angles. So we know that the interior angles of the triangle, the 3 together, add to 180. So I'm going to write this here in our plan. So we know that the measure of angle X plus the measure of angle A plus the measure of angle Y are equal to 180 because they are interior angles of a triangle. So again, here, since it's only the plan, I'm writing the reasons in a simplified form, but when we write the proof, we will write complete definitions or complete theorems. So that's what we know about the 3 interior angles of the triangle. And now the second question, what do we know about the linear pair of angles, which is angle A and angle Z? Well, we also know that linear pairs add to 180, so we can write this here. So measure of angle A plus measure of angle Z is equal to 180. and that is because they are a linear pair. And now, if we look at the conclusion that we want to get, which is up here, it's one equation. So we need to combine these two equations one more time into one equation. And since both of these equations equal to 180, we can use the transitive property to combine these two equations into one, because we have these two quantities that look totally different, but they are both equal to the same quantity, which is 180. So that makes these two quantities equal. So I'm writing this over here. So because they are both equal to 180, we know that the measure of angle x measure of angle x plus measure of angle A plus measure of angle Y is equal to measure of angle A plus measure of angle Z. And that is because we're using the transitive property. I'm not going to write it here because I don't have space, but remember that is the reason for writing this statement is the transitive property. And now we can see here in this equation that we have measure of angle A repeated on both sides of the equation. So if I get rid of this measure of angle A on both sides, we would have exactly what we want, which is that the measure of angle X plus the measure of angle Y is equal to the measure of angle Z. So we're going to do that again. We're going to subtract measure of angle A on both sides. So we get rid of these two measure of angle A's on both sides, leaving us with exactly what we want, which is the measure of angle X plus measure of angle Y is equal to the measure of angle Z. And this would be because we're using subtraction. Okay, so now we go to write the proof, which should be just a matter of putting the same statements that we have here in the same order, just in a very organized way, using complete definitions or theorems or properties as the reasons. So we look at the proof that I already wrote down. It's here. So you should have exactly the same thing as the plan. Even if you plan mentally, you should know exactly what is it that you're going to write from beginning to end. So here it is, step number 1, measure of angle X plus measure of angle A plus measure of angle Y is equal to 180, because interior angles of a triangle are to 180. And in number 2, I have measure of angle A plus measure of angle Z is equal to 180, because linear pairs are to 180. And then in step number 3, I have combined the two equations into one. So measure of angle X plus measure of angle A plus measure of angle Y is equal to measure of angle A plus measure of angle Z, because we use the transitive property to combine these two equations into one. And then I'm showing you one more time the subtraction, which you really don't need to show. And the result of the subtraction is measure of angle X plus measure of angle Y is equal to measure of angle Z using the subtraction property. So we have shown that if you have a situation like the one that we have in the diagram, then the exterior angle is equal to the sum of the two opposite interior angles. We have proved that the theorem is true. Notice that here, nowhere we have used that theorem in the reasons or in the statements. We cannot use whatever we're trying to prove, we cannot use. So we have used other things. We have used interior angles of a triangle, we have used a linear pair, transitive property, and subtraction in order to get to this conclusion. So that is proof number 2. and that is from page number 1. I'm going to leave page number 2 of the worksheet for you to practice. Those are going to be your practice exercises. If we were in the classroom, you will be working also in groups to complete the proofs, and then the groups will present those proofs to the class. So I'm going to leave this page number 2 for you to do it by yourselves, but make sure you complete them. And in the next lesson, we're going to check them. So please make sure you complete so you can follow me on the next lesson and see what you did correctly and what you need to work on. So that's it for today, and just do your practice exercises for the next class.